Hey, good morning, students. This is Mrs. Kramer. I hope you guys are great this morning. I am. It is April the 15th, and it is a Wednesday. And today we're going to continue reviewing exponents. Something that I've noticed with some of you that have turned in some of your activities with the exponents and some of the questions you've had for me are having to do when a number is raised to the zero power. And I need to go over with you that anytime a number is raised to the zero power, as long as that number is not zero, it would be equal to 1. So I have on my board that the variable x to the zero power would equal 1 as long as x does not equal 0. So if you have 5 to the zero power, that's going to equal 1. If you have 100 to the zero power, that's going to equal 1. If you have 200 to the zero power, that is also going to equal 1. So any number raised to the zero power is going to equal 1 as long as that number that you're raising to the zero power is not 0. So I hope that kind of clears up that misconception. I've tried to write each of you notes that were struggling with that. And if you're still having trouble with that part, please reach out to me by email or in the Google Classroom, and I will continue to help you. Today we're going to add reviewing rational exponents. Now, a while back, last year, we covered rational exponents with a challenge paper, and the majority of you all did that paper. So whenever you have rational exponents, remember rationals are numbers that can be written as fractions. So our exponents are going to be in the form of a fraction. So I have for you this first one is 25 to the 1/2 power. Well, that's going to equal the square root of 25 because the 2 tells us we're going to take the square root. So the square root means 2. So we want the second root of 25. And then we're going to raise it again to the first power. So that 1 in the numerator is why I'm raising this again to the first power. The number in the denominator tells me what root I want. So I have to think to myself, what number times itself twice equals 25? Well, it's 5. So the square root of 25 would be 5, and then I raise it again to the first power, which means there's only one 5, so it still equals 5. So that's how I've set up for you to be able to see how to do 25 to the 1/2 power. My other example that I want to do with you is 27 to the 1/3 power. So I've got 27 to the 1/3 power. The number in the denominator of my fractional exponent tells me what root I need to take. So I'm going to need to take the third root of 27 and then raise it again to the first power. So that's why I have a 1 here. So I have to think to myself, what number times itself 3 times equals 27? Well, it's 3, because 3 times 3 times 3 equals 27. So my third root of 27 is 3, and then I'm going to raise it again to the first power. So 3 to the first power, there's only one, that means just 1 3 would equal 3. So I have some other examples that I'm going to do with you. So we're going to work on simplifying each expression. So if I have 125 to the 1/3 power, that means I want the third root, and I'm going to raise it again to the first power. So I've got to take the third root of 125 and raise it again to the first power. What number times itself 3 times equals 125? It's 5. So my third root of 125 is 5. Raising it again to the first power, it would still equal 5. My next example is 81 to the 1/4 power. Okay, so I've got 81. The 4 in the denominator tells me I've got to find the fourth root of 81. So I need to think to myself, and then I've got to raise it again to the first power. So I've got the fourth root of 81, raised again to the first power. I've got to think to myself, what number times itself 4 times equals 81? Well, 3 does. So the fourth root of 81 would be 3. And then I take it again to the first power, and it would just equal 3. Let me back off so you can see that one in the whole thing. Okay, the next thing I'm going to do is I'm going to mix it up a little bit. I'm going to take 121 to the 1/2 power plus 256 to the 1/4 power. So I have to take the square root of 121 and raise it to the first power, and I've got to take the fourth root of 256 and raise it to the first power. So if I think, I want the square root of 121, which is 11, and I'll raise it to the first power, and that's going to be 11. And then I want the fourth root of 256. Well, what number times itself 4 times equals 256? 4 times 4 times 4 times 4. So the fourth root of 256 is 4. And when I raise it again to the first power, it's still just equal to 4. So 11 plus 4 would be 15. So I'm going to back out so you can see all of that one. And my last example is 64 to the 1/6 power plus 25 to the 1/2 power. So I've got to think, okay, what is my 6th root of 64? And then raise it again to the first power. And my square root of 25 and raise it to the first power. Well, 2 times itself 6 times equals 64. So my 6th root of 64 is 2, and my square root of 25 is 5. So if I carry that over here, 2 plus 5 would be 7. So I'll back off so you can see that one. So those are some examples for you to be able to refer back to. I am going to post a few problems for you to try and attempt out in the Google Classroom. Make sure and ask me questions as you're working on them, and I am happy to help you with those. And if you use the Google Classroom, that makes great collaboration for all students that can see it and see your questions. You guys can answer questions to each other, and I would encourage you to do that. I know sometimes it takes a long time for me to get back to you. I just am having tremendous response from you guys, from everybody, from all of my students with this online learning. Don't give up on it, guys. I am here for you. I want to help you. It is a great day to be a Minuteman. Have a wonderful day. #Minutemen all in. Bye-bye, guys. I'll talk to you again soon.